Okay, students, after completion of yesterday we learned construction and working of Daniel cell. So today we shall learn mainly how to represent the Daniel cell. Not only Daniel cell, for every electrochemical cell, the representation should be done in this manner. Okay, what is the sequence we have to follow for writing the representation of Daniel cell means A, B, C. It is the sequence we should follow. A refers to anode, B refers to bridge, that is nothing but salt bridge, and C refers to cathode. In the representation of anode, always metal should be written first, followed by the metal ion. Zn bar Zn plus 2. Bridge. Bridge is represented by double vertical line. How the bridge is represented means bridge is represented by double vertical line. Next, C refers to cathode. It is the representation of Daniel cell. It is the representation of Daniel cell. Zn bar Zn plus 2 Cu plus 2 bar Cu. It is the representation of what we are getting means Daniel cell representation we are getting like this. Since if you know the concentration of electrolyte ion here, if you know the electrolyte concentration here, we can also mention that one also. So it is the representation of Daniel cell. It is the representation of Daniel cell. Sometimes, okay, the representation will be given in the question. From the representation, we have to write the overall reaction. We have to write the overall reaction. So such type of questions also we can get. Okay, the representation will be given in the question itself. From that, we have to write the overall reaction. Suppose it is the representation given like this. From this representation, we have to write the overall reaction. Okay. So this is the anode, and this is what means cathode. Anode equation. What is anode equation? Anode always oxidation takes place. Cathode always reduction takes place. Okay, in the overall reaction, number of electrons should be balanced and cancelled. Number of electrons should be balanced and cancelled. For balancing number of electrons, total equation, we are multiplying with 2. Now 2 electrons will remain cancelled. Now, how can you get this overall reaction means Cu plus 2Ag plus gives rise to Cu plus 2 plus 2Ag. It is the overall reaction we are getting like this here. Okay. In this way, representation is given means we must be able to write the overall reaction. Okay, try one more example. Suppose this is the representation given for you. For this representation, we have to write the overall reaction. Okay. Something. Next, it is the anode equation. Cathode equation. It is the cathode equation. Okay. So see here, number of electrons are not equal. So we have to first of all balance the number of electrons. So this equation we can multiply totally with 3. This equation totally we can multiply with 3, and this equation we can totally multiply with 2. Then electrons is now been equal. Now we can cancel the number of electrons. Now you are getting the overall reaction in this manner for this representation. In this way, representation is given means we must be able to write the overall reaction. We must be able to write the overall reaction. Okay, next topic we shall discuss here, how the Daniell cell will behave if an external EMF is connected. How the Daniell cell will behave if an external EMF is connected. So this is the Daniell cell to which we connected some external EMF. We connected external EMF. Totally we shall get here three cases we shall get here. This is the anode. Totally we can get three cases here. First case is totally we can get how many cases means three cases. First case, external EMF is less than 1.10. If external EMF is less than 1.10, there is no problem to the functioning of cell. Cell will function in normal manner. Cell will function in normal manner. Electrons are flowing from anode to cathode and current flows from cathode to anode, and during the process the weight of zinc electrode decreases and the weight of copper electrode increases. Okay, there is no problem to the function of cell if external EMF is less than 1.10. Second case is external EMF is exactly equal to 1.10. If external EMF is exactly equal to 1.10, there is no movement of electrons. There is no movement of electrons. If there is no movement of electrons means we can say there is no production of electric current and chemical reaction stops. This is the second case we are getting if external EMF is exactly equal to 1.10. And case 3 is external EMF is greater than 1.10. If at all external EMF is greater than 1.10, now the cell will behave in an opposite manner. Instead of behaving like electrochemical cell, now it will behave as the electrolytic cell. Okay, if external EMF is greater than 1.10, last case, okay, the cell will behave in an opposite manner. Instead of behaving like electrochemical, it will behave like which cell means electrolytic cell. Electrolytic cell means what we can say, okay, here now a non-spontaneous process will take place. Electrons now they will flow from copper to zinc and current flows from zinc to copper. Electrons flow from copper to zinc and current flows from zinc to copper. Okay, the cell behaves in a opposite manner. Instead of behaving like electrochemical cell, it will behave like a electrolytic cell. And during the process, if external EMF is greater than 1.10, during the process the weight of copper electrode decreases, at the same time the weight of zinc electrode what happens means increases. Okay, the cell will behave in a non-spontaneous manner. Okay, in that we can call it as what means cell will behave like a electrolytic cell. Electrochemical cell will behave like a electrolytic cell. Okay, so this is about it. Okay students, next we are discussing about the modified form of Daniell cell. In modified form of Daniell cell, what is the modification we have did here means the salt bridge has been replaced by the porous pot. Salt bridge has been replaced by the porous pot. Okay, the salt bridge is not there in the modified form, you can see. Instead of salt bridge, what we have taken means here porous pot we taken, except that the remaining as usual the cell functions in a normal manner. Okay, the outside vessel it's made up of copper and it is containing copper sulfate solution. It will act as the cathode. The inner vessel is containing zinc rod dipped in zinc sulfate solution. Will as usually function as the anode. And the anode reaction, cathode reaction are also same. Anode reaction is this, the anode reaction cathode reaction. We are getting the overall reaction also same. But what is the modification we have done? He did here means instead of salt bridge, what we have taken here means porous spot we taken. What we taken here means porous spot. It is the only the modification we did here. Okay, here if the salt, you may get the doubts, sir, without the salt bridge, how the neutrality will be maintained? Means here the neutrality will be maintained by the movement of sulfate ions from cathode into the anode compartment. Here the neutrality will be maintained by the due to movement of sulfate ions, from cathode compartment into the anode compartment, into anode compartment. In this way, neutrality is maintained in a salt bridge. Neutrality is maintained in the modified form of Daniell cell, which is not containing the salt bridge, Here neutrality will be maintained in such a way that the sulfate ions will move from cathode compartment to anode compartment, through the porous spots, In this way, what will be maintained means neutrality will be maintained. We know that in cathode, negative charge will be created due to the excess of sulfate ions. In anode, we are getting excess of positive charge. Now, due to the movement of ions, sulfate ion, the negatively charged sulfate ions from cathode to anode, neutrality will be maintained. What will be maintained means neutrality will be maintained, and cell will function in normal manner. It is, we can say, as the modified form of Daniell cell. Okay, thank you, students.